Today we're going to pull back the curtain on a field that sounds super complex, but is actually the secret weapon economists use to figure out how the world really works. We're talking about econometrics, the toolkit for turning big economic ideas into actual real-world insights.
You know, it's one thing to have a theory, right? To say something like, if you lower prices, people will buy more. It sounds logical, it makes sense, but is it true? And if it is, how much more will they buy? That's the huge gap that econometrics was designed to fill, moving from just an idea to cold, hard proof.
And the name itself actually gives away the game. Economics literally just breaks down to economic measurement. So at its very heart, it's all about measuring what's happening in the economy. But just measuring stuff isn't enough. You have to connect it back to a theory.
I want you to think of it like this. On one side of a huge canyon, you've got economic theory, all the big ideas, the what-ifs. And on the other side, you've got the messy, chaotic, real-world data. Econometrics is the bridge you build between them. It uses the tools of statistics to see if the ideas on one side actually show up in the data on the other.
And this right here is the fundamental difference. Economic theory gives you a qualitative statement. It describes a relationship, right? If price goes down, demand goes up. But econometrics, it gives that idea teeth. It provides the numbers. It tells you exactly how much. A 10% price drop increases demand by 15.5%. It takes a general idea and makes it specific, testable, and incredibly useful.
So how in the world do they do it? Well, it's not just a shot in the dark. There is a method to the madness, a reliable step-by-step process that researchers follow every single time. You can think of it like a recipe, or maybe a blueprint, for putting any economic idea on trial. And here it is, the 8-step blueprint. We're going to walk through this exact process, and we're not going to do it in the abstract. We'll use a famous, real-world example to see just how a simple idea gets transformed into a powerful tool that can actually shape government policy.
So for our case study, we're tackling the spending puzzle. We're going to put one of the most famous ideas from the legendary economist John Maynard Keynes on trial, using the tools of econometrics to see if it really holds up.
All right, so step 1, state the theory. Keynes laid out what he called a fundamental psychological law, and it's pretty simple. He said when people get more money, they spend more, but they don't spend all of the extra money. They save some of it. This means the rate of extra spending for each extra dollar, what he called the marginal propensity to consume, or MPC, has to be somewhere between 0 and 1.
Okay, on to step 2. How do we turn that idea into math? Well, in a perfect world, Keynes's theory looks like this beautiful, clean equation. Consumption, that's Y, is equal to some baseline spending, that's beta 1, plus a fraction of our income, X. And that fraction, that beta 2, well, that's our MPC. That's the magic number we're hunting for.
Yeah, right. Of course not. The real world is messy. Countless other things affect how much we spend. You know, your age, whether you have kids, how confident you are about the future. A perfect straight line is way too simple. So we have to account for all that real-world messiness.
And that brings us to step 3. And this is the absolute genius of an econometric model. We add one more thing to the equation, this little u. That's the disturbance or error term. And what it really represents is everything else. All those other factors, all the randomness of human behavior that we can't perfectly predict. This little u is what makes our model embrace reality.
Step 4 is pretty straightforward. We need data. You can't test a theory about the real world without real-world data. So to test our model, we're going to use data on the U.S. economy. Our Y is consumer spending, and our X is GDP, a good proxy for national income from 1960 all the way to 2005.
And now for the really cool part, step 5, estimation. We take all that data and we use a statistical technique called regression analysis. Now that sounds complicated, but all it's really doing is finding the single straight line that best fits that messy cloud of data points. And when we do that, this is the equation we get.
And right there, that is our answer. The number we've been hunting for is 0.72. This is our estimated MPC. What it means is that, on average, for every extra dollar of income the U.S. economy generated, people spent about 72 cents of it. So for step 6, we test our hypothesis. Is that number between 0 and 1? You bet it is. The data seems to support Keynes's theory.
Okay, so we proved a theory. That's great for academics, but who cares? Well, the real power here is that this isn't just an exercise. Now that we have this model, we can actually put it to work. We can go from just analysis to real action.
So let's try step 7, forecasting. We can use our shiny new model to try and predict the future.
We know that the actual GDP for 2006 turned out to be about $11.3 trillion. So let's plug that number for X into our equation. The math tells us that consumption spending should have been about $7.87 trillion.
So how did we do? Well, the actual number for 2006 was a little over $8 trillion. We were off by about $174 billion. Now, that sounds like a ton of money, but for an economy that massive, it's actually incredibly close. You're never going to get it perfect, but that's a really powerful ballpark estimate to have. And now we get to the final step. Step 8, using the model for policy. This is where it gets really interesting. There's this idea in macroeconomics called the income multiplier. It's basically the ripple effect. The idea that one new dollar of spending, maybe from the government, ripples through the economy and creates even more income. And the formula for that amazing ripple effect? It depends entirely on the MPC, the very number we just spent all this time estimating.
So if we plug our MPC of 0.72 into that formula, we get a multiplier of about 3.57. What on earth does that mean? It means our model suggests that every new dollar of investment could ultimately boost national income by $3.57. For a policymaker trying to stimulate the economy, that number is pure gold.
And here's the payoff, the whole point of this entire process. Economics gives policymakers a real tool to help steer the economy. By changing a control variable, like income, maybe through a tax cut, they can try to hit a target variable, like getting consumer spending up to a level that keeps unemployment low. Our model can literally give them an estimate of what level of GDP they need to shoot for to make that happen.
So, we've seen this incredible journey, from a simple idea in a book to a number that can guide massive policy decisions. But it leaves us with one last, really big question. What happens when two competing theories, say one from Keynes and a different one from his rival, Milton Friedman, both seem to fit the data pretty well? How do you choose which one is right? That is the kind of challenge that sits at the very frontier of econometrics. And it's the question that keeps pushing the whole field forward.